derivatives of x to power n, where the n is negative or a fraction. Okay, so let's say, for example, now you have this one, y equal to x to power minus m, and here the exponent or the power is negative. Okay, so how do you do this case? The differential coefficient for this case, y dx, will be equal to the negative power will go to the front. Okay, then the function itself minus 1. So that's how to do that. It's the same thing with the positive exponent. Okay, let's also assume that we have y as square root of x, where you have the radical. So how do you take care of these square roots? It's very simple also. What we have to do is to remove this radical, so which will be equal to x to power half. Then after that, then you start differentiating. Your differential coefficient will be equal to what? The half will go to the front, and then the function x half minus 1. So, and that will be with this now, you're going to have half times half minus 1. That will be x minus half. So that doesn't stop there. You need to go further and do the algebra. Okay, the algebra in the sense that you need to remove the negative exponent here, which will be equal to this minus mean 1 over x half. Okay, and then with that you have 1 times 1, 1, and then this one times this one, that will be 2 what? 2x half, which is equal to 1 over 2. X to power half is root x. So you return it back to what? To the radical at the final stage. So that's that on that case. Okay, we have a lot of questions here to play with, so that we can explain all these cases, okay, in detail. We have one, so that will be ddx, the function of x, ddx of the 3 is there, cube roots of x. So the step 1 we do, we have to remove these cube roots. Okay, and for you to do that, that will be equal to ddx of x to power 1 over 3. X to power 1 over 3. Okay, and so that's that, because we've already established in the indices that when you have something of this nature, okay, we believe that there is one here, there's one here, or there is one here. Okay, so the one inside the root will be division of the power. Okay, so that will be equal to x. This one will be your numerator, and this will be what? Denominator. Okay, you can also have, for example, you can have something of this nature, x2, 3. If you want to remove it, this will be equal to what? X. This will be your numerator, and this will be your denominator. So that is that on that case. So you can watch the video on indices in this channel. Okay, so that's that. So let's go straight to the solution of the problem. So this will now be equal, the 1 over 3 will go to the front based on the law of differentiation. Then the function itself, 1 over 3 minus 1. And that will give you 1 over 3 times x to power 1 over 3 minus 1. That will be 1 minus 3. That's minus 2 over 3. So, and your final answer is just 1 over 3. Remove this negative here, which will be 1 over x2, 2 over 3. So your answer is what? 1 times 1, 1, and then 3, x, 2 over 3. So that's that on that. And that will take us to question 2. Question 2, we want to differentiate with respect to x, which will be dx of the problem. This is 3 here, cube root. Then we have 7. So as I've said earlier on, this will be equal to, the first thing you can do for you to differentiate this is for us to remove the radical, so which will be equal to x. I told you the power here will be the numerator of the exponent, and the what you have inside the root will be denominator of the what of the exponent. Okay, so that's step one. If you cannot remove it, you'll not be able to differentiate. Then the next thing to do, the 7/3 will go to the front, and that will be x 7/3 minus 1, and that will give us 7/3 times. This will be 7 minus 3, that's x 4/3. If you do the 7/3 minus 1, that will be 4/3. So 4/3. So that's that on this case. Then we go to question 3. Question 3, we have, if you like, you can give it, let y be equal to what? 2x squared minus x. Okay. Now you can see, now you have to remove this radical, which will be equal to x squared minus x to the power half. So you can see in this case now, your exponent is a fraction. Okay. For you now to find the y, the x, it's very simple. Your power will come to the front, and then power minus 1, that's minus half. Then the next thing to do is to get the derivative of this base, okay, which will be equal to times 2x squared, that's 4x. Derivative of x is what? Minus 1. Okay, this is what we call the functions of functions, whereby it's as if we are giving this base a letter, so we're having something like b half. Okay, so if you differentiate b half, you're going to have half v, and then this one minus 1, that will be minus half. That's what we have done here. Half v, this is my v, and then minus half. Okay, then this v also is also a function of something. Okay, this v is a function of what? It's a function of x. So then you have to differentiate what? Differentiate the v with respect to x, and that's that. Okay, so that's what we have here. Then the next thing to do is to, this will be equal to 1 over this minus here is 1 over 2x squared minus x half, and then times 4x minus 1. So what can we do now? The final thing is this one times this one times this one. So that will be equal to 4x minus 1 all over 2 into bracket. You can now return this one back to the what? To the original format of the question. That's square root. Half as a power is square root, and that will be 2x squared minus x. Okay, so that's that on that question. Goes to question 4. Yeah, question 4. Let's call it y. Let's call the question y. Let y be equal to what? 1 plus sine x. Yeah, square root. Can you remove the square root? That will not be wasting time. So that's half. So in this case now, your y prime will be equal to, the half will go to the front. Then we have 1 plus what? Sine x. And then half minus 1. Half minus 1 is what? It's minus half. Okay, and then times the base of that expression. This is the base. The base here is 1 plus sine x, and this is the exponent, I mean the power. Okay, so times the derivative of this base, which will be equal to what? Derivative of 1 is 0. Derivative of sine is what? Is cos x. Okay, that's that. The only thing we just need to do is just to do the algebra and arrange properly. So this minus 1 will be 1 over. Okay. Want to find the derivative of this one. Can we give it we have dx of, remove the square root, that will be 1 plus x over 1 minus what? 1 minus cos x. So this is what you have. You have square root of that. Okay, so step 1, can you remove the square root, which will be equal to 1 over d dx of 1 plus sin x over 1 minus cos x, all to power what? All to power half. That's step 1. Step 2, you need to differentiate, which will be equal to your power, come to the front. Okay, the expression 1 plus sin x over 1 minus cos x, and the half minus 1, that will be minus half. Half minus 1 is minus half, and then times the derivative of the base of that function, d dx of 1 plus sin x over 1 minus cos x. So if you're having problem with this kind of question, please go to the one of the videos we've discussed functions of functions. So, and we have spent time there to really dissect functions of functions. Okay, so let's go on. So DDS of this, and don't forget this is a quotient rule also. So there's also a video on quotient rule. Please check the video and watch that video on quotient rule. Okay. So DDS of this now. So this will now become 1 over 2. We can do this one. This is what? This minus a is 1 over. This minus a is 1 over 1 plus sin x over 1 minus cos x, or add half. Then hit this one now. We can open bracket for this. This is the quotient rule, which will be equal to 1 minus cos x squared. That's your b squared. Then the b will be here, is your denominator 1 minus cos x. Then derivative of the numerator, which is what? Which is cos x. Okay, then minus the numerator 1 plus sin x, times derivative of the denominator. If you differentiate cos, it's going to give you minus sin x, and then times this minus a. That's what? That's sin x. Okay, so that's what we have now. Then the next thing to do is to do the expansion. This one will be equal to 1 over 2 times, this will be 1 over this half as a power. We can deduce it now, which is what? 1 plus what? Sin x over 1 minus cos x. And this one will give me square. Then this one times 1, that's cos x. This cos x times cos x minus cos square x. And then sin x times 1, that's a minus sin x. Okay. I'm opening this bracket also. So sin x times sin, that's a sin square x times the minus. So minus what? Minus sin square x. Okay. These two, we can bring it together. So that will be equal to, we're going to have here cos x minus sin x, cos x minus sin x. And then we can factorize minus here. Minus is here, minus is here. Take the minus out. Then you have cos square x plus sin square x all over 1 minus cos x all square. And this one, don't forget this one. There's 1 here, 1 on this fraction. So it's going to flip this one. It's going to flip it upside down. So that will be equal to half into brackets. I said this one will be flipped upside down. This is a fraction, and there's 1 on top, so it will become 1 minus cos x. 1 minus cos x over 1 plus sin x. Okay, square root, and then times cos x plus sin x. cos x cos x minus sin x, then minus 1 all over 1 minus cos x all square. Okay, so that's what we got there. Then the next thing for us to do now is for us to remove these radicals, so we can combine this one together with this one. Okay, so that will be equal to half into brackets. This one is having 1 minus cos x. Okay, half minus 2, because this is division, so the minus 2, they have the same base. This one is having power of half all over 1 plus sin x power half. So into brackets cos x minus sin x minus 1. So, and this will give me 1 over 2 into brackets 1 minus cos x. If you subtract this one, that will be minus 3 over 2 over 1 plus sin x half with square root. That will be square root straight away. Then times cos x minus sin x minus 1. So that's the question. That's the solution to that. You can try this on your own. Try this one on your own. Try this 1 plus cos x 1 minus cos x. Try this. Differentiate this. And let's see your answer. The step is similar to what we've gotten on the board. So try that. So we'll go to the last question. We have d dx of square root of what? X minus 1 over x plus 1. So that's the question. I want to differentiate that with respect to x. So this will be equal to d dx of x minus 1, x plus 1 power half. So which will be equal to half into bracket x minus 1, x plus 1, then half minus 1 minus half, and then times the derivative of this, of the base. Okay, you have the base. The base is what? X minus 1 over x plus 1, and this is your power. The derivative of this base, which is a fraction. And then for fraction, you use quotient rule. So that will be equal to what? Times x plus 1 power 2. Okay, then x plus 1, that's a b, times the derivative of the numerator, which is 1, then minus numerator, then the derivative of the denominator, which is also 1. Okay, so in that case now, this is x, this is minus x. So, and this is minus times minus 1, that's plus. So we're going to have half times 1 over this minus here, x minus 1 over x plus 1 half times, this will be 2, 1 plus 1, 2 over x plus 1 all square. And this one, you have a fraction here, and there is 1 here. So you are reciprocating the fraction. So which will be half into bracket. So this will flip upside down. So that will be x plus 1 over x minus 1 half. Okay, and then times 2 over x plus 1 power 2. Okay, these two will cancel out. Then you have x plus 1. This is the power half. X plus 1 is there. X plus 1 is there. So half minus 2 all over x minus 1 half. Okay, and this will give us x plus 1. This will be half minus 2, that's minus 3 over 2. Yeah, that's 1 minus, no, half minus 2, that's 4, 1 minus 4. Yeah, minus 3 over 2 all over x minus 1 half. So that's the answer, except if you want to remove the negative exponent. If you want to remove the negative exponent, it's very simple. It's just be equal to, this one will be 1 over x plus 1 power 3 over 2, and then times 1 over, this one is now, there's 1 here, 1 over, okay, 1 over x minus 1. And if you like, the half, I'll put in the inside square root. So that's the end of these differentiation, and involve negative exponent or fraction as a power. Okay, so that's that on that. Please, so if you are new on this channel, please hit that notification bell so that as we upload, you get notified. Thank you for doing that.